All right, this is where a Venn diagram and knowing our notation is going to be helpful. And the tricky part about this is that these two events are not going to be mutually exclusive. They are not going to be mutually exclusive. So, probability that the person has pierced ears is the first thing we're finding. So the person has pierced ears, so we're going to look at pierced ears, yes, and that is out of everybody. So how many have pierced ears? That's going to be 103 out of everybody. So 103 out of 78. That is the probability of B, if we're defining A to be male, B to be pierced ears. So this is the probability of B. Is a male with pierced ears? So we need them to be a male and we need them to have pierced ears. So this is the probability of A and B. So we're looking at the overlap between being male and having pierced ears. So in other words, the probability of A and B, which remember we wrote as A intersect with B. Probability of A and B. So we look at the people who are both male and have pierced ears. That is our 19 out of 178. For part C, we're looking for them being a male or having pierced ears. So this is the probability of A or B. Now we're using union. Probability of A or B. So when we did this on Tuesday, we said or probabilities we would usually add. So how many do we have that are male? Well, we have 100. We have 90. How many do we have that has pierced ears? We have 103. Add those together and we get 193 out of 178. Oh, wait a second. That can't be right. What happened? So these 19 people got counted twice in both of these categories. So they were counted in the males, they were counted in the having pierced ears. So we counted them twice. So let's take those 19 away so that we only count them once. And when we do that, we get 174 out of the 178. The other way that you can do it is that you can count all three of the people in these sections. The easier way to do that is to say the probability of male or pierced ears is 1 minus the probability of being neither. If they're not male or have pierced ears, then that means they've got to be these 4 people. These are the only ones that aren't male and also don't have pierced ears. So take those 4 away and you're left with the other 174. So that's another tricky part of these probability problems is that there are a few different ways to look at it and a few different ways to explain it. But the way that I showed it here is if we just add the 2 categories and then take away any double counting we have, that is the general rule of or probabilities. So the probability of A or B, this is going to be the formula that's on your formula sheet on the AP test. So this is important. The probability of A plus the probability of B minus the probability of both. Because if they're in both, then we just double counted them. And so we want to subtract it so that instead of counting them twice, we only count them once. This is going to be an important rule. Now, when we had two things be mutually exclusive, like yesterday, we didn't have to worry about subtracting off the double counting because the probability of A and B was 0. Because we said mutually exclusive meant it was impossible for them to happen at the same time. These two things are not mutually exclusive. In other words, you can be male and you can have pierced ears. Those two things can happen at the same time. So when that happens, we need to take away the double counting. Okay, next slide is kind of recapping the ideas that we just talked about here. This is another visual way to illustrate what we just did, which is that we can draw a Venn diagram. So here's everything. And then remember that this is in A and not in B. This is in B, but not in A. This is in both. So here's your A and B. And so really, what's in each of these is we have 19 in the overlap. The amount that's in A and not in B is 71. And the amount that's in B but not in A, that's going to be 84. So it matches those numbers that were in the table. And then out here, there's 4 that's in neither category. So whichever way you want to think about it as far as the visual or the Venn diagram, but the basic rule is probability of A or B is probability of A plus probability of B minus probability of both. And then this slide I've talked about already. We've talked about the complement of an event. Remember, complement means not A, anything not an A. And we talked about mutually exclusive, which would be if there's no overlap between the two events. If it's impossible for A and B to happen together. And then let's talk about, here is intersection, here is union. And my trick for you was U for union and N for intersection. If a Venn diagram doesn't help you, that's okay. The homework is going to ask you to do some two-way tables, some Venn diagrams. So I'm going to show, I got 2 different examples. We're going to do it 2 different ways. We're going to do the first one with a Venn diagram. We're going to do the second one with a table. And then going forward, the homework is going to ask you to do both. But in general, I want you to use whichever idea clicks with you better to find these OR probabilities. So I'm going to do part A without the Venn diagram, with just the typical ruled probability, and then we'll make the Venn diagram. So find a probability that the person reads at least one of the 2 papers. So I'm going to do T for USA Today, and I'm going to do N for the New York Times. I'm not going to use U because I'm going to use it for union. So the probability that the person reads at least one of them, so that is the probability of of T or N. T or N. And that's going to equal the probability of T plus the probability of N minus the probability of T and N. So the probability of T, the probability that they read the USA Today, is 0.4. Plus the probability that they read the New York Times is 0.25. But then if we do this, then we are double counting the people who read both. So the probability of T and N is the people that read both the USA Today and the New York Times, and that is 5%, so 0.05. So we have 0.4 plus 0.25 minus 0.05. That's going to be 0.6. Oh, the second circle went better. That's a bit better. All right. So we are going to use, we're going to use T for the USA Today. We're going to use N for the New York Times. So first off, the overlap is the easy part. The overlap is 0.05. Then in this circle, we would want the people who read the USA Today but don't read the New York Times. So there's 40% that read the USA Today, but then 5% that read both. So we want to take that 5% away, and we're left with 35%. So 0.35 goes in here. That is in the USA Today, but not the New York Times. Then over here, we want the people that are in the New York Times, but not in the USA Today. So that is 0.2, taking away the 5% that are in both. Then out here is the people who read neither. So we have 60% that are in these categories, that are in one circle or this circle or both. So that leaves the people that are in neither circle to be 0.4. The other 40% are out here in neither circle. So the probability, that is the probability of neither. So that is A and B, or sorry, stated wrong. A or B complement. Neither would be A or B complement, which means that it's 1 minus the probability of A or B. So the probability of neither is 1 minus the probability of either, 0.4. If you're doing your Venn diagram right, just like your probability table, it should add up to 1. So I get 0.35 plus 0.05 plus 0.2 plus 0.4 adds up to 1. Or if you're doing it number-wise, like on the last problem, then these numbers, 71, 19, 84, and 4, should add up to the total of 178. That's the same thing as saying these probabilities add up to 1. So we all know that we have 52 cards in a deck. There are 4 suits. We have hearts, diamonds, clubs, and spades. Jack, queen, and king are called face cards because they have faces on them. Sometimes they're also called picture cards because they have pictures on them. But usually they're called face cards. So I want you to start by making the two-way table. So read up on what event A and event B are. And hopefully from there, you should be able to get this. So A is getting a face card. And B is getting a heart. So how many of each are in the deck? Your totals down here should be 52. See if we can make that two-way table. Here we go. When I'm filling out this two-way table, I find the easiest way to do this is by filling out the totals first. So the total amount of hearts, we say that each suit has 13 cards, so there's 13 hearts. That leaves not a heart to be 39 cards that are not hearts, because there are 13 in the other three suits, so 13 times 3, that is 39. Then we have our face cards. We know that they're Jack, Queen, and King, and there are 4 suits, so 4 suits times 3 face cards each equals 12 total face cards, which leaves 40 of them to not be face cards. So then when we go within ourselves, we know that these should add up to, across the rows, 12 and 40, and across the columns, 13 and 39. So how many are face cards that are hearts? Well, we have 3 of them. We have the Jack of Hearts, the Queen of Hearts, and the King of Hearts. And off with their heads. 3 of them. That leaves 10 of the hearts that are not face cards. We have the 2, 3, 4, 5, 6, 7, 8, 9, 10, and ace of hearts. These are hearts that are not face cards. Then we have the face cards that are not hearts. So these are the 3 face cards in each of the other 3 suits, so 9 of them. And that leaves 30 in this column that aren't hearts or face cards. Questions on this table? So that's the way I like to organize it, get the totals first. Part B, someone give me the fraction here. So 3 out of 52, that is in both categories. It's a heart and a face card. There's 3 of them out of all 52 cards in the deck. If you add something else in the denominator here, you're thinking ahead to the next section. In the next section, we'll be talking about questions like how many of the hearts are face cards? Or how many of the face cards are hearts? That's what we're going to talk about next section. Right now, we're just asking how many are hearts and face cards. There's 3 of them out of the 52. So we can't say that probability of A or B is just the 2 added together. There's a couple different ways to explain this, but the idea that we're getting at is that here we are not mutually exclusive. Because the probability of A and B is not 0. Right? The answer to this was not 0. You could say that there are people, there are face cards here that would also be hearts. So we are double counting if we were to just add them together. So our general addition rule, the probability of A or B, the way that we should do this, is again the probability of A plus the probability of B minus the probability of A and B. So that is probability of A, that is, let's see, A was our face card, so that is 12 out of 52. Plus the probability of B, that is 13 of them out of 52. That's how many of them were hearts. And then we want to take away double counting the face cards and the hearts. Instead of counting them twice, we want to count them once. So 12 and 13 is 15 minus 3, or sorry, 25 minus 3 is 22 out of 52. And you can either reduce that fraction or you can get the decimal out. But 22 out of 52 are in either category. You can also do it with a Venn diagram. Anything else like that. We'll do another couple examples with these next week just to kind of review and familiarize ourselves with that. But that is section 2. I will give you a homework assignment so that you can have something to start working on today and tomorrow. Remember, tomorrow we're doing simulations.